an international e-conference. For today's session on the dais is Honorable Keynote Speaker, Dr. V.Vaidhehi ma'am. So I heartily welcome to you, madam, for this national conference. I welcome the chief organizer of the series, Honorable Dr. M.M. Bedkar sir. And also, I heartily welcome all those dear participants. The topic for today's presentation is data engineering. The topic is going to present, as I have mentioned, today's keynote speaker, Honorable Dr. V.Vaidhehi ma'am. She is serving as an associate professor at the Department of Computer Science, and she is from Christ University, Bangalore. So with this brief introduction, now I request to you, madam, please start your presentation on the topic data engineering. You are most welcome.
Thank you, sir. Hope my screen is visible.
Yes, madam.
Yes, ma'am, that's it. That's it.
Yeah. Good evening, all. Today's talk is about data engineering. This is a buzzword in the field of computer science and especially in the field of artificial intelligence. So I'm going to give you a brief introduction about data engineering and its applications and its challenges. So I have planned my talk on this points for today's presentation. We will discuss about fundamentals of data engineering, architecture, life cycle, and ecosystem of data engineering, and benefits and the tools related to data engineering, and then challenges and future of data engineering. And I would also like to introduce some of the data engineering projects that are available in the market. So going on to data engineering, this is very interesting point. Like everywhere we are hearing the word data, and now whenever we look at data, it is in massive volume. So nowadays, day by day, when you see you have WhatsApp, you have any social media, Twitter data, Facebook data, and each one as an individual, we are having lots of access to data. Now, this is what is the recent statistics that is being shown. Like we would have 463 exabytes of data per day by 2025. Exabyte is equivalent to 18 followed by 18 zeros. So imagine the biggest number, that much of data every individual will be accessing. Now, engineering is a very important word here. Now, we would have heard like civil engineer, mechanical engineer, one who builds the appropriate element. Say, for example, one who constructs a building, or one who does the wiring part of it, electronics part of it, electrical part of it. So all these are engineers. They are the constructors of the components. Similarly, data engineers are building data for using. So you are coining a very, very important term called as data engineer, who is responsible for giving you the data that you want. So engineers build any and everything, but data engineers are the one who is building you the data. So what is the goal of a data engineer? The data engineer is the one who is responsible to build a quality data that is useful for fact finding and data-driven decision making. And he is also responsible so that the data is scalable. That means it is increasing day by day. You should be in a position to handle that much of volume of data. So he should be responsible for that. These are the two major roles that a data engineer should keep it in his mind. So these are the goals for a data engineer. Now, is it a new word, or is it available from our history? Yes, it is available right from 1980s, the data engineering. It is available under the name of data warehouse in 1980s, and in 1990s, it is master data manager, and in 2000s, it is available and it is stored in data lakes. And now in 2019 onwards, during that pandemic time, it has taken a different scale. Data engineer and data engineering process is widely spoken in computer science world, and especially in artificial intelligence. So now we are in this fourth generation of data engineering process from 2019 onwards. Our goal is to build intelligent data pipelines and data lakes. Now everybody would be knowing what is a pipeline, the one which carries water, or the pipeline is the one wherein the wires are carried over our streets. Telephonic wires are being carried. So they are a messenger of for the thing. Say, for example, water pipelines, they carry water. Wire pipelines, they carry wire. Signal pipelines, they carry signal. Similarly, data pipelines are the ones which are responsible for carrying data from one point to another point in our globe. So data engineering is a kind of software engineering that focuses mainly on data infrastructure, data warehousing, data mining, data modeling, and data crunching, and metadata management. These are all the key features for data engineering. So you are going to see in what infrastructure you are going to build the data. As you have seen in the first slide, the volume of data that you are going to handle. Similarly, what is the warehouse that is needed? Now, what is a warehouse? At home, you will keep one room for storing your long used things, warehouse or storehouse, you will call it. Similarly, here, data warehouse is a storehouse wherein all historical data or used data, or however you call it, you will be storing that in a storage environment. That we will be calling it as data warehouse. And data mining is you are going to extract the data. Is it okay? Am I audible?
Yes, ma'am. Yes.
Yeah. So data mining is a responsible activity wherein you are going to dig the data out from the data warehouse, and you are going to use the data for your decision making. And the next part is data modeling. Data modeling is you are going to model the data for your need, and data crunching is a set of processing activity you will be doing it so that you will get little more insights on your data. And then metadata management. Thank you, sir. Metadata management is you are going to manage the overall data of it. So this is what is a quick evolution of data engineering that we are speaking out. So now we are in the fourth generation of data engineering. We are going to handle more of intelligence data pipelines and data lakes. Data lakes are larger storage mediums. Now, going forward, whenever we speak about a person who is designated as data engineer, what are all the different roles he is going to play in an organization? So he is responsible for governing the data, and he is responsible for securing the data, that he is responsible for handling it. Okay, so data security, data privacy, data governance is very, very important activity of a data engineer. Coming down line, you do have the data engineer has to wear different hats. He has to handle the data. He has to process the data. Now he will be responsible for performing ELT process: extract, load, and transform. This is the explanation of ELT. You, as a data engineer, has to extract the data from different data sources. It has to be loaded into different data storage mediums, and it has to be processed or transformed for processing it further. So ELT or ETL, there is a difference in building the data. So this, again, these are again the responsibility of a data engineer. Then coming downline, different data storage handlers. He should be in a position to store the data in different storage mediums, different platforms. He should be in a position to handle, and also he should handle big data. Again, a different variety of an ordinary data, big data. He has to handle. Then comes the next part of it. He has to integrate the data. That is, he has to consolidate the data from different mediums, and then he should be in a responsible position for building the data pipeline. Okay, and then that pipeline becomes a repository for future processing. So if you take the task of a data engineer in a clockwise manner, you could see, as a data engineer, you should have a different capability to perform and handle different tasks. So in an organization, the role of a data engineer is very, very important. And if you are seeing the current role, the growth of a person in a computer industry, IT segment, basically, you could see one point as it is ranked 4th. Data engineers' growth is expected to be growing every year on a 38% growth rate. That means imagine the need of a data engineer in an IT industry. So the job opportunities are plenty. When you have learned or upskilled yourself in these lines, your grabbing the job market would be very easy. Now, coming to another things, what you wanted to learn when you wanted to become a data engineer, what you wanted to learn. Basically speaking, you should know more about this SQL, Python, Spark, and I have listed few technological terms here, and these are the top 10 technologies that you should be aware of if you want to become a data engineer. So this is as per the job listings of 2020. Now also, again, Python and SQL are leading the market. Again, if you have taken 20 technologies over x-axis, again, I have listed many technologies further in this slide, which gives you an idea like what are all the technologies one should be aware of if you want to if you are planning to become a career in this area of data engineer. Okay, now coming to the data engineers in different industries, in different domains. Now, the need of data engineers is very well depicted in this chart. The data engineers are required in almost every industry, from IT segment to defense. If you have seen, the requirements are growing year by year. So there is a high demand in the market as well. Now, what are all the companies? If you look at that, again, the data engineers are required. If you have taken all IT related companies, right from HP, Amazon, Facebook, Capital One, everything, you can see the requirement of the data engineers in their organizations. If you have taken, HP requires more than 200 engineers on an average per year. Right. So every industry, if you could see, there is a requirement. Even Uber is there, Yahoo is there. You can name any company, and every company, there is a designated data engineer for that. So it marks the importance of this course called as data engineering. Now, what as a data engineer, what is that he's expected to do in an organization? Currently, what is that he's doing is he spends lots of his energy in performing these activities: cleansing the data, organizing the data, and formulating the data set, and then mining the data for patents and other data related jobs. This is how his job profiles are there. Okay, so now you could also see a transition shift from this perspective to the future data engineering perspective. For that purpose, I have introduced this slide here. So right now, most of the data engineers are spending most of their time in cleaning the data and organizing the data for whatever the domain in which they are working. It marks a light, simple introduction on data engineering. Now, you could also see a data engineering team for every industry. So if you could see a data engineering team for every industry, this is how it goes. You would see a data consultants, data custodians, because they are the people who are securing your data, data lakes or storage areas, monitoring and infrastructure, data infrastructure, data pipelines, data warehouse is this part, database experts and data modeling, and finally comes performance tuning. These are the entire members that collectively they are forming a team called as data engineering team for their organization. So it is not one man's job, it is a collective effort of many people involved, and everybody has to wear different hats. As I have shown earlier, you as a data engineer, he has to perform multiple activities, and similarly the team is a hybrid team. So one should be expert in data warehouse, one should be an expert in modeling team, one should be in custodian, security purpose. Okay, it is a collective effort, and together the data engineering team of an organization is formed. Now coming to the next part of the data engineering, that is an architecture behind. As a technologist, and now as a current 21st era AI technologist, what should I do if I want to become a data engineer? So what is an architecture behind this process? So if I see this architecture, it is a 5-layered architecture. You can see from this. This is the first layer. This layer is called as data ingestion layer. And then you take this into coming from data collection, you are going to do as a second step as data processing, and then the third step parallelly what is happening here is data storage. So if you see in this way, horizontally, you have two things. One is data processing happening and another one is data storage and integration. And when these two things are ready, now your data is ready for analysis. So you have to do as a first step, data has to be collected, that is called as data collection or data ingestion. Then the second step and third step can be interchanged since it is a parallel activity. You can do data storage and you can also process and then do the data storage. This is where the difference comes in our pipeline construct. And once this is done, you can analyze the data. Now, once this process is ready, now the data pipeline building comes in. So that is our fifth layer. This is what is an architecture behind any organization for data engineering. It is surrounded by 5 layers: data collection layer, data processing layer, data storage layer, and then data analysis layer. And finally, you have a common layer which connects every layer, that is nothing but your data pipeline. It is an invisible layer or visible layer between any two layers. Okay, so that is called as data pipeline. Now, when I talk about life cycle, as a data for a data engineering activity, where should I start from? I have to start from the first layer. What was our first layer? Data collection layer. So we should start our life cycle activity right from the first layer, and you can see this mark as a cycle activity. You have to start it from first layer. So you are going to collect the data. That is nothing but data collection, okay, from different source. So what are all the activities you would be doing? You have to extract the data, and you have to integrate the data, and then that data gets little more organized now because you have integrated it from different sources. And then that integrated data again should be stored in some of the storage mediums. That storage mediums could be data warehouse or data lakes. Now, this data cannot be used directly. It should undergo processing. It will be in raw format. It should be processed. That will be done in the second stage of the data engineering life cycle. You will undergo cleaning activities, transforming the data from one type to another, or representing the data from one model to another data model. So these are all preparing your data for further processing. So that will happen in this processing stage. And then you would also design very important activity called as pipeline design. Here we are going to design data pipelines. Basically, there are two data pipelines: extract, load, transform, ELT, and ETL pipelines, which are responsible for loading and storing the data. And then here, one more activity also plays a vital role, our data custodian's role. Who will safeguard your data? Okay, what are all the security measures that is being done in this stage? So this stage is very crucial in data engineering life cycle. Now comes the third stage called as architecture stage, wherein you should identify an appropriate storage medium for storing your data. So that today's data, what is the volume that you are getting? For future data, say after 2 years down the line, whether the same storage medium, can I use it to see the futuristic vision of the scale of data, say how much volume I am going to get after 2 years from the same input sources. Is it the storage medium sufficient to handle those volume of data? The scalability plays a vital role in the design of data repository. That comes the third stage, and the fourth stage is data access. Whoever wants the data, if you want to run any of the reports or dashboards, you can make use of those data. That is the user of the data. This is what is the stage of the data engineer. Data engineer struggles to collect the data, process the data, and keeps the data ready for analysis. So the first, second, third stage is the very crucial stage of a data engineer. We are going little more detail about the source step. What is the first stage? Data source, collection source. So collecting the data from multiple sources. What are all the variations you can expect? There is a variation in the type of data. There is a variation in the format of data what you have. From the storage medium, there is a difference, and repositories, there is a difference. I'm coming little more in detail about the type of data. What you can see is there is a variation in a type of data, like the data could be structured, or it could be unstructured, or it could be semi-structured. What do you mean by structured data? If I am talking my formal English, it is a structured speech. But if I am talking it in a colloquial way, it becomes an unstructured way, right? To put it in very simplest form. Now, when it comes to technological part, when you can identify a person with some attributes, like I am a person working in such and such place, doing my specialization in such and such, you can have some attributes tagged to me. That becomes my structured data. Whereas unstructured means you cannot have a fixed attribute for those data. Unstructured. Okay, a passage of text is given. You have to read, comprehend, then only you will identify what is that text talking about, right? That becomes an unstructured, because you don't have a tabular representation. Say, for example, you have a session and you can say 1, 2, 3, 4, 5 as serial numbers, speaker name, designation, topic, and area of interest. Whatever you club it, you put it as a tabular form, it becomes easy for us to have a understand, right? It is easy to understand. By looking at the data that is being represented in tabular way, it becomes very easy for you to understand. The same data you have written as a paragraph, but there is no title. You are not telling anything. I have to read every line, comprehend, understand properly, then only I'll come to know like what is that paragraph talking about. So this is called as unstructured. Now you do have an in-between category called as semi-structured. Some are points, bullets, which is easily understood. Some you have to spend some time in reading and comprehending properly. That is unstructured. There is a type of data. Differences in these categories. Similarly, formats. Everybody would be knowing. Some text would be in document form, PDF form, JSON, Excel file, and CSV file, XML. You can add any other formats as well. There is a difference in your data formats. Similarly, where is the source? The data is coming from different databases, and you have different ways in which you can have the data storage. One is relational databases, another one is flat files, APIs, you do have web scraping, etc. Similarly, data repositories, data warehouse, database, data mart, data lake. These are all different repositories, due to which as a data engineer, he has to integrate the data from these differences, accessing, you have to query it, okay, and then data has to come from different sources. One has to consolidate it, process it, cleanse it, integrate it, and give it to the next user. So this is a very, very challenging task in this first stage of data engineering activity. Now, extraction. Again, how do I extract the data? You should know different query languages, different application programming interface, that is APIs, web scraping, feeds. So Twitter feeds, I should know, data streams. Say, for example, traffic light management. If I am running a project, it is a continuous, every millisecond you should be watchful. Where is the traffic? Which light signal is on? Which signal should be off? All those things. So that is a live data coming in. If you have installed sensors, the data coming from the sensors are a live data. So that we will be calling it as data streams. So again, the first stage itself, you have lots of challenges in handling all those things. Now coming to the second stage of data engineering, where you are going to spend your entire time in performing the processing the data, that is called as data wrangling. Data wrangling is nothing but cleansing. It is a 6 activity done together. Okay, so every step is a detailed process here. Cleansing, enriching the data, validating the data, publishing the data, discovering the data, and structuring the data. Entire 6 steps is each one is a tedious task. And in the second stage, the data engineering process, okay, the data engineer has to perform this 6 processing tasks based on the need of the data. Now, during this process, he will be building data pipelines. Those pipelines are 2 types. One is ELT and another one is ETL. There are 2 types of pipelines. One is you extract the data from different sources, load it, and then do the transformation process. That is the first type of pipeline. ELT, extracting, loading, and then transforming the data. Now, you do have another thing called as ETL, extract the data, immediately perform the transformation process, and load it later, store it later. Load is store. Now, based on the need, when you are working with live stream data, that is, when you are working with sensor-based data, you will be doing this process. As soon as the data you are getting it, from the sensor, you will be storing it, and then only you will perform the transform operation. And then if it is a normal data, then what you can do is extract, transform, and then store. So based on the need, you will build any of these two pipelines. Coming to the last segment of the second stage, the security concern, safeguarding the data. You have to maintain different levels of security, infrastructure-wise, network, within your infrastructure, and then application data security. And also you should also remember, recently in India, we do have Data Protection Act being passed, Digital Personal Data Protection Act. That also you should, when we are working with our Indian industries, we should also remember these protection acts, okay? Because this is a three-step process. You should have a confidentiality, integrity, and availability. These, see, data should be available to everyone. Data should be integrated, okay? And then confidentiality. That means everybody cannot get every access in your organization. Principal will get, or vice chancellor will get to access certain data, and head of the department will get to access certain data, and you as a faculty will get to access certain data. So there is a differences in accessing the data. So you need to maintain the confidentiality at any cost. So this is the very important activity that is being performed in the second stage, data security, and then data governance. That is also equally important, because data governance is nothing but the collection of principles, practices, and processes that are to be used to maintain the data. At what level the data should be maintained at to maintain the security, privacy, and integrity of the data. Okay, so this is very important. So data governance policies of any organization plays a vital role in data engineering process. So what is the authentication? Who has to access which data? I cannot access everybody's pay, or you have a restriction, right? Everybody cannot access every information that is available, right? So the access control is equally important. So this governance plays a vital role in allocating the access control for every employee in that organization. And is that data directly stored? Because nowadays we are having lots of issues in our messages, right? Everybody will be fraudulent messages we are getting. Many are being misusing their rights. Some links, bad links are being sent. Unknowingly, we are clicking, our money is getting going lost. So we are hearing many things, right? So you should also know what is encryption and how the data is masked in your storage mediums, and who is the host, and is there any alert? Say, for example, when you are within the organization, have you installed the firewall? Is there any unauthorized access being noticed? If so, what is the immediate alert message that is being generated? And what is data erasure? Who sees if somebody comes in? Is he doing any unwanted activities? Is he erasing any of our data? Is he rewriting anything? So all these things are to be governed in such a way that our data originality is maintained. Nothing is lost. Now, third stage is data modeling. It is nothing but data storage mediums. Predominantly, we are going to talk about different storage mediums: relational storage mediums, non-relational storage mediums, data warehouse, data mart, and data lakes. And each has its own limitations, and each has its own advantages. So this is all about a data model. The data model is one wherein you are going to organize the data and you are going to store the data. So the data repositories are nothing but data storage mediums. What is a relational database? Relational database is useful for storing structured data. And the non-relational databases are used for storing unstructured data. And then data warehouse is our homes storage rooms. Anything and everything you can dump it in our shelf or in our room. So that is nothing but your data warehouse. Any data, because you will think that that file will be used for future. This data might be required for my future reporting. So that is data warehouse. Data mart, again, a combination of structured and unstructured, because here the sizes might vary. That is all. Nowadays, we are talking more about data lakes. Imagine the space, the capacity of the lake. It is huge. So you can accommodate or dump more and more data into it. Now, which is that you should choose? How will you choose your data repository? It is done based on the type of data that you wanted to store in, okay? And then the volume of data that you wanted to store in, and the intended usage of the data. It plays a vital role in choosing the different data repositories and other storage considerations. By looking at the data, can I say that it is a structured data or unstructured data? And also your custodian's work, like privacy, security, and governance of that organization, plays a vital role in identifying an appropriate data storage. Now, to give you a little more insights, you have right from Oracle, MySQL, Microsoft SQL Server. These are all different servers or databases. Now, out of that, the popular database again ranks as Oracle. So Oracle is a predominant structured database, and here you can see unstructured database as well, and some are open source databases as well. So you can see a variety of databases. Okay, so this to just give you an idea, like what are all the popular databases and which is at the top now. Now coming to little more observations. In an organization, say for example, HR maintains its own data, CRM, customer relation data is maintained separately, then ERP of that organization is maintained in different. This symbol marks about a database. This symbol marks about a database. So HR database, customer relations database, and ERP, the company's ERP module. So then you do have a non-relational database being maintained, all soft copies of images or whatever the documents you wanted to maintain, a manual of an instrument or whatever it is, you do have a non-relational data that is being separately maintained. Now, these two can be modeled together and can be dumped in your data warehouse. That is what I would like to bring into your attention. Relational and non-relational together can be stored in your data warehouse. Similarly, a data warehouse, you can also have smaller versions of data warehouses that is called as data marts. Say, for example, for the overall organization, it is data warehouse. If you try to maintain it as a region-wise, say, for example, South region, North region, East region, I have maintained the subset of the data warehouse that becomes your data mart. Again, this data marts, you have different varieties in building the data mart. It could be dependent on the main, or it could be independently built, or it could be hybrid, both dependent and independent. Now comes the fourth data repository, that is data lake. Now, all these process, the stages, what we have seen, it all depends on our target audience. Who is going to use? Is it the target audience, or the AI application developers, or data analysts, wherein they wanted to analyze data more in depth, okay, or data scientists? They will be building many machine learning models. Okay, so it all depends on the audience and the requirements. So the data engineer job, their role is to create the data, and it could be used by any of these people. Now we are coming to the next segment of our discussion, that is ecosystem. Now, if you wanted to live as a human, you do have an ecosystem. You need an appropriate temperature, you need water, you need shelter, you need food, and then you will have a plant which is grown in your area nearby, and then animals which are available nearby. So it all forms your ecosystem, wherein you can also live peacefully, and your chain of people also can live peacefully, like animals, plants, and other organisms, right? Similarly, a data engineering ecosystem. How do you define data engineering ecosystem? It all depends on the infrastructure of an organization, framework of an organization, tools being used, and processes what you define for your organization. This collectively forms a data engineering ecosystem for any organization. Now, what is the benefit of data engineering process? Definitely, for any organization, for that matter, the opportunities are increasing day by day because of this data engineering process, so that they can widen their scope of business. They are being agile, they can have they can increase their efficiency, and they could generate more revenue, and they can do better decision making when they have a proper data engineering system that is in place in an organizations. And also they can take appropriate actions based on the growth, and you have enough data for you to take the decisions. The decisions are being validated by your data. Logical validations can be possible here. And then best practices can also be seen with better data engineering activity for an organization. And it all depends on your target audience, whom you wanted to design this process. Is it your focus to improve your business, or is it your focus to increase the sale of a particular region? And anything and everything is possible with respect to data engineering activity. Now, what are all the tools that are available? There are many tools available, and here what I have done is I have segmented those tools based on the data engineering life cycle, that is the collection, processing, and storage. So based on that, these are the set of tools that are commonly used. Say, for example, Kafka. And then here you can use SQL and Spark for processing it. And you can also use your data warehouse, NoSQL, depending upon your storage mediums. Predominantly Java, Python, Ruby, these are all the languages that are used to build your data pipeline. Now, is there any certifications possible? Who can become a data engineer? Say, for example, Google provides a professional data engineer certification certified by Google. Similarly, a data engineering certification provided by IBM. And you do have Microsoft certified Azure data engineer, because every platform is different. So you can choose a platform and you can become a data engineer certified in that platform. And these certifications carry multiple values to your resume. And then what is the roadmap of it, and how can you become a data engineer? The first point I would like to mention here would be the passion and enthusiasm for your data-driven decision making. It is not something which comes directly to take any decisions. The decision should be taken based on the data that is in front of your hand, right? So that is very important when you are talking about data-driven decision making. Okay, so that is the enthusiasm for you to do it. Now, the second one is learning this structured query language. SQL is a must for you. And then the knowledge of programming or scripting language like Python, Java, again, it is a compulsory thing. Then understand the fundamentals of cloud computing like Amazon's web services, Google cloud platform, or Microsoft's Azure. Any one platform of cloud computing also plays a vital role. And then warehousing tools and ETL tools is important. And then data skills, big data skills, Hive, Spark, PySpark, and normal Spark. That is, these are the 6 points that I have mentioned, which will take you to being in the towards your career. in data engineering. Now, what are all the challenges? Definitely, there will be a challenge in accessing the data. Again, building accurate and quality data becomes a challenging part of it, and computational resources would be a great challenge, and the performance. See, you would be running a query and you are handling a big data. It might take a few minutes, or sometimes it is even a longer hours for you to get the result of your query. Okay, so these are the major challenges that one faces in data engineering. Okay, so finally what I could say is, what the data scientists see is the tip of the iceberg, but what data engineering see is again a deeper down dive into it. That is what I would like to mention here. Data engineers play a vital role in understanding the larger picture of the data. So it is not an easy task. It takes lots of time, lots of energy. That is why they are paid very high in any organization. Now, when you see the demand of data engineer and data scientist, data engineer is marked in blue and data scientist is marked in red. And every time you could see there is increased requirement. And based on my introductory lecture also, you could analyze that always there is a higher demand of data engineer in the market. And then what does the future of data engineering look like? Okay, so earlier they were spending lots of time in cleaning the data, right? I was mentioning in the earlier slide. Nowadays, they will be, the future would be like, they would be likely to use cloud technologies more, and they would focus more on monitoring the data, and they will switch the teams from feature teams to foundation teams. So from 5 layers, it could be reduced to 3 layers. Now I would like to show this project. Is my screen visible?
Yes, ma'am. Yes.
Quickly, I will show you 1 or 2 projects and then we will conclude it. There is a data engineering project website, Project Pro, and you can see this project website. 20 plus data engineering projects are there. I would like to show you 1 or 2 projects, how it is being done and what are all the things that is being used. Now they have 30 listed projects in the website. For a beginner, we can take that project statements and you can try, because they have given the sample code and they have given a brief description about every project. If you look at that aviation project, you have a complete roadmap of it, what they have done, where they have used Hadoop, where they have used Hive, and how the Kafka is used. And then they have a New York City Management System, event data. Whenever there is an event happening in New York, it is a open data that is available, because I have done this project. And then what data modeling, whatever we have spoken, technical part of it, how this Kibana is used, what is the role in exploratory data analysis, how that APIs are used, how the data moves from one place to another place. Okay, so this project. And then similarly, you do have next project. This is a data ingestion project. Like that, you have plenty of projects that are being listed, and we can take one domain and we can understand, because every project is done in different platforms, different tools. So we can understand and we can see what is the effect of this data engineering from this website. We have different projects available. Okay. And then this is done based on this ELP data set. So this data set will help you to understand the details. Okay, and then you can download a Google Cloud Platform, and then all those required APIs, and then we can have that sample code is also available with every project, so that for a beginner, we can understand the flow of the project. And then this is what is my conclusion, like to want to become a data engineer. as a profession, you first understand the basics of the programming, learn automation, and then you can understand your databases, you can master your data processing activities, and then you have to schedule your workflows properly, and then cloud computing is mandated here, and then you can also study about infrastructure, and then the recent trends. You should be very, very responsible in catching up with the recent trends. If you follow these 8 steps, definitely you can become a data engineer. So happy learning and keep learning is my message. And then I would like to conclude by telling this new quote of data engineering: data engineers are the new kings and queens of artificial intelligence. Thank you all for giving me the wonderful opportunity.
Thank you so much, ma'am. Dr. V.Vaidhehi, ma'am.
Yes, sir.
For the wonderful explanation on the topic data engineering. Now it's a time for interaction with keynote speaker. Dear participants, if you have any query, would like to share something, please come ahead.
Good
Dr.
evening,
Kendra,
ma'am.
sir.
Good evening, sir.
Ma'am. And good evening, all of you. Thank you, Honorable Principal Dr. M.M. Bedkar, sir, Prashant, sir, and all organizing committee members. Thank you so much, ma'am. You have made a very nice presentation and wonderful and excellent presentation. Your lecture is very informative, excellent session. I have some question, ma'am.
Yes, sir.
Question is very simple. First question is, what exactly does a data engineering do? Second question is ETL part of data engineering?
Yes, sir. To address your first question, data engineer is a person who builds the data. And how does he build the data? He has to go to different sources to collect, consolidate, and keep the data ready for others to read and understand, to put it in very simple form. Hope I have answered the first question. Data engineer's role is to create the data or build the data. See, as a civil engineer, I will be building a bridge. As a electrical engineering, I will be building a electrical transformer. Similarly, as a data engineer, I have to build a data. Which data? What is the purpose? Where do I collect? What should be the appropriate format? All those things I should understand and build the data. That is the role of data engineer. Now, okay. Now, what is ETL? Is extraction of data, loading the data, and transforming the data. ETL. This is a part of data engineering process.
I think that your explanation is a very wonderful and excellent.
Thank you.
Thank you so much, ma'am.
Thank you.
Thank you, Principal Dr. M.M. Bedkar, sir, and Prashant, sir.
Thank you, sir. Again, Shyam Suresh Giri, sir. Please.
Good evening, ma'am.
Good evening, sir.
Good evening, Dr. Bedkar, sir, Prashant, sir. I'm very happy for this and excellent guidance. After many days, I have seen such a enrichable presentation and very accurate speaking and very useful and nice guidance for me. I think data engineering is a milestone of human progress. And my question is, how do you compare ancient and modern data engineering?
Sir, now older ones, no, there were lots of challenges. Why? Because your data varieties were not this much, and your storage was a major constraint. Because you have to spend lots of money in identifying your storage mediums. Nowadays, the storage medium cost is little less, but you have variety of data. And you have sensor data coming in, live stream data coming in, and all those things. So now I would say that the cost is less, but you have lots of challenges in keeping up the storage.
Thank you, ma'am. While listening your lecture, there were many questions in my mind, but you already answered. So my next question is, what are the challenges in future in data sciences?
Sir, again, the handling of live stream data would be challenging, sir, because it comes with every microsecond, right? Or even lesser than that. That sensor data processing would be challenging, sir.
Okay, thank you so much, ma'am.
Uh, I think there is no one now because Madam have explained. I'd cover all the details
Yes,
without any break continuously 55 minutes. She was going to talk in the session. So thank you so much, Honorable Dr. Devidas Kendre sir, Sham Suresh Giri sir, for your nice interaction with keynote speaker. Now I request the Chief Organizer of our National E-Conference, Honorable Dr. M. Bedkar sir, to conclude the session. Please, sir.
Thank you, Professor Prashant Ughade sir, and today's resource person, Dr. V.Vaidhehi madam, who is associate professor from Department of Computer Science, Christy University, Bangalore. Also the well-known participants, Professor Devidas Kendre sir, Sham Suresh sir, and all those who are joining daily. So today's topic was related to data engineering. We are all teachers not related to engineering and technical side, but you made the subject very simple. What is data? How the work of engineering data? How it can be handled? What are the job opportunities? What are the risks and all these things? So basic information about this unknown topic to mostly of us you have cleared. It was the best study speech and best presentation also with proper appropriate titles and charts, diagrams. So everything was so clear that which storage leading companies having more storage, all these things. So these types of informative examples and speeches can enhance the knowledge of those who are not from engineering side, but it is very important field of data engineering because every second data is created, it should be generated, it should be kept safely, and it should be analyzed clearly. So these all sections and cycles you have cleared. Sham Sundar sir also explained, reacted. Devidas Kendre sir also. So we enjoyed this technical session, and in future also you will be invited for such a kind of informative speeches from you. Thank you, madam, and thank you to our madam, those who have invited you as a resource person.
Thank you, sir.
Veena, which madam that have introduced you? Nisha madam. I'm thankful to Nisha madam also. Thank you.
I'm here, sir. I'm here.
Okay. That I mistake that name. Thank you. Sorry for miss that understanding.
It's okay. It's okay, sir. It's
Yes.
okay.
Thank you, ma'am. Thank you.
Sir, all the best wishes for your milestone, Bedkar sir.
Yeah, credit goes to all resource persons because they are accepting invitations, joining here, and they have kept our audience perfectly. Because everyone they get a different knowledge, different speeches with different resource person well known, and they are master of their field. They do research on that, or they study before after accepting our invitation. So this type of intellectual continuously we are continuing from last 4 years, and credit goes to all for joining members and also resource persons and those who are promoting as like our Nisha madam. Thank you.
thank you, sir.
Thank you, sir. Thank you. And best wishes, Bedkar sir, for your journey.
Thank you. Please wait for formal vote of thanks.
Thank you, sir. Now I move towards the vote of thanks. Shri Kumarswami Mahavidyalaya Ausa, District Latur in Maharashtra State. As we know, all dear participants, we are organizing national conferences, international conferences, World Record Series. We have started since 4 years before, and continuously we are doing this activity only to provide the different kind of knowledge in front of all kinds of teachers and any members from different faculties. Now this become the culture of Shri Kumarswami Mahavidyalaya, that to provide very informative knowledge in front of the peoples. So with this intention, we are moving ahead And for today's session on the dais was Honorable Dr. V.Vaidhehi ma'am. Came with a new topic. Before also have heard from many resource persons, they have talked about the data engineering, this topic. But today madam have explained and cover all the aspects regarding the topic data engineering. What is the data engineering, its fundamentals, also task of data engineering, data engineers in different domains, data engineering architectures, then different data engineering tools, data integrations, data extractions, data security, role of the data engineering, and data storage, benefits of data engineering, the complete roadmap, and how will be the future of data engineering. Now these points you covered very clearly. Point to point presentation was there, madam. Really, we are very happy to listen you in today's session. So I express my sincere gratitude towards you. You paid your valuable time to the series. Thank you so much. I also thank the chief organizer of the International Conference, Honorable Dr. M. Ambedkar sir, who is the ideal principal of Shri Kumarswami Mahavidyalaya Ausa. And I should not forget this Dr. Devidas Kendre sir, Shyam Suresh Giri sir, we have nicely discussed in today's session. And at last, I should not forget all those dear and sweet participants who joining regularly makes us motivates and also enhance the beauty of the session series, this world record series and international conference. So thanks a lot once again to you all. Kindly, I request you all, please fill the feedback link which is given in the chat box. So with the kind permission of chief organizer, I declare today's session is over. Bye-bye to you all. Again, we meet at proper 7 o'clock tomorrow. Thank you so much, Dr. Vaidhehi madam. Again to you. Take care. Bye-bye.
Bye, sir. Bye.